Yes, an APC UPS battery backup can be used to keep motor starters on during a loss of power. To do this, firstly calculate the power requirements by determining the total power consumed by all 8 motor starters and the control circuit. Secondly, select a UPS with a capacity that exceeds the power requirements by 20 to 25% for a safety margin. Thirdly, connect the UPS to the 120 volts control circuit that powers the motor starters. Fourthly, configure the UPS, setting it to UPS mode or power saving mode to keep the control circuit powered even during power outages. Fifthly, verify operation by testing the UPS by unplugging it from the power source and checking if the motor starters remain energized. Other considerations include battery life. The UPS battery will only power the motor starters for a limited time during a power outage. The duration depends on the UPS capacity and power consumption. To provide extended backup power, consider connecting a backup generator to the UPS. The APC UPS also provides surge protection, which can protect the motor starters from voltage spikes that may occur during power outages. Ensure proper wiring and overcurrent protection for all components, including the motor starters, control circuit, and UPS. Alternative solutions include automatic transfer switches, or APCs, which can automatically switch to a backup power source, such as a generator, when the main power supply fails. Isolation transformers can provide short-term backup power for critical loads, such as motor starters, during power outages. When determining the appropriate UPS size, begin by calculating the total power consumption of the motor starters and the control circuit. This can be done by summing the wattage of each component. Consult the nameplate data on the motor starters and any other devices connected to the 120 volts control circuit to determine their individual power consumption. Add all of these values together to arrive at the total power consumption in watts. Once you have determined the total power consumption, select a UPS with a capacity that exceeds this value by 20 to 25%. This safety margin ensures that the UPS can handle any unexpected spikes in power demand and provides some headroom for future expansion. UPS capacity is typically specified in volt amps or vol. To convert watts to volt amps, divide the total power consumption in watts by the power factor of the load. If the power factor is not known, a value of 0.8 is a reasonable estimate for most electrical loads. For example, if the total power consumption is 1000 watts and the power factor is 0.8, the required UPS capacity would be 1000 watts divided by 0.8, which equals 1250 volt amps. Select a UPS with a capacity of at least 1250 volt amps. After selecting a suitable UPS, connect it to the 120 volts control circuit that powers the motor starters. Ensure that the UPS is properly grounded and that all wiring connections are secure. Connect the input of the UPS to a dedicated 120 volts outlet that is not shared with any other loads. This will help to prevent overloading the circuit and ensure that the UPS has a reliable source of power. Connect the output of the UPS to the control circuit that powers the motor starters. This may involve connecting the UPS to a distribution panel or a junction box. Make sure that all connections are made in accordance with the manufacturer's instructions and that all wiring is properly insulated. Once the UPS is connected, configure it to operate in UPS mode or power saving mode. This will ensure that the UPS automatically switches to battery power in the event of a power outage. Consult the UPS manufacturer's instructions for specific details on how to configure the UPS for these modes. Some UPS models may also offer additional features, such as automatic voltage regulation and surge suppression. These features can help to protect the motor starters and other connected equipment from voltage fluctuations and power surges. After configuring the UPS, verify that it is operating correctly by testing it. Unplug the UPS from the power source and check if the motor starters remain energized. If the motor starters continue to operate, the UPS is functioning as expected. If the motor starter shut off, there may be a problem with the UPS or the wiring connections. Double-check all connections and consult the UPS manufacturer's instructions for troubleshooting tips. It is important to note that the UPS battery will only power the motor starters for a limited time during a power outage. The duration depends on the UPS capacity and the power consumption of the motor starters. To estimate the runtime of the UPS, divide the UPS battery capacity in watt-hours by the total power consumption of the motor starters in watts. For example, if the UPS has a battery capacity of 1000 watt-hours and the motor starters consume 250 watts, the estimated runtime would be 1000 watt-hours divided by 250 watts, which equals 4 hours. Keep in mind that this is just an estimate, and the actual runtime may vary depending on factors such as battery age, temperature, and load conditions. To provide extended backup power, consider connecting a backup generator to the UPS. A generator can provide a continuous source of power during a power outage, allowing the motor starters to operate for an extended period of time. When selecting a generator, choose one with a capacity that is sufficient to power all of the connected loads, including the motor starters, the control circuit, and the UPS. Connect the generator to the input of the UPS using an automatic transfer switch, or ATS. The ATS will automatically switch to the generator when the main power supply fails and switch back to the main power supply when it is restored. This ensures a seamless transition between power sources and prevents any interruption in power to the motor starters. In addition to providing backup power, the APC UPS also provides surge protection. Power surges can damage sensitive electronic equipment, such as motor starters, and cause them to fail prematurely. The UPS contains surge suppression circuitry that can protect the motor starters from voltage spikes and other power disturbances. Ensure that the UPS is properly grounded to provide effective surge protection. Proper wiring and overcurrent protection are essential for ensuring the safe and reliable operation of the motor starters, the control circuit, and the UPS. All wiring should be sized appropriately for the current that it will carry and should be installed in accordance with the National Electrical Code, or NEC. Overcurrent protection devices, such as circuit breakers or fuses, should be installed to protect against short circuits and overloads. These devices should be sized appropriately for the wiring and the connected equipment. Consult the NEC for specific requirements on wiring and overcurrent protection. In addition to using a UPS, there are other alternative solutions for providing backup power to motor starters. One option is to use an automatic transfer switch, or ATS, to switch to a backup power source, such as a generator, when the main power supply fails. ATS are typically used in critical applications where it is essential to maintain power to the load at all times. Another option is to use isolation transformers. Isolation transformers can provide short-term backup power for critical loads, such as motor starters, during power outages. They work by storing energy in their magnetic field and releasing it when the power supply is interrupted. Isolation transformers are typically used in applications where a brief interruption in power is acceptable. When selecting a backup power solution, consider the specific requirements of the application, the available budget, and the desired level of reliability. A UPS is a good option for providing short-term backup power and surge protection. A generator with an ATS is a good option for providing long-term backup power. Isolation transformers are a good option for providing short-term backup power in applications where a brief interruption in power is acceptable. To summarize, using an APC UPS battery backup can be an effective way to keep motor starters on during a loss of power. By calculating the power requirements, selecting a UPS with sufficient capacity, connecting the UPS to the control circuit, configuring the UPS properly, and verifying its operation, you can ensure that the motor starters remain energized during power outages. Consider also the battery life of the UPS, the possibility of connecting a backup generator, and the surge protection provided by the UPS. Ensure proper wiring and overcurrent protection for all components. Alternative solutions include automatic transfer switches and isolation transformers. By following these steps, you can provide a reliable backup power solution for motor starters and prevent them from shutting down during electrical storms or other power outages. Always consult with a qualified electrician or electrical engineer to ensure that the installation is safe and in compliance with all applicable codes and regulations. They can help you assess the specific requirements of the application and select the appropriate equipment and wiring methods. Regular maintenance and testing of the UPS and other backup power equipment are also important to ensure that they are in good working order and will perform as expected when needed. This includes periodically checking the battery voltage, cleaning the equipment, and testing the transfer switch. By taking these precautions, you can minimize the risk of power outages and ensure the continued operation of critical equipment. In addition to the technical aspects of using a UPS for motor starters, it is also important to consider the safety aspects. Working with electricity can be dangerous, and it is essential to take precautions to avoid electric shock and other hazards. Always disconnect the power supply before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can cause serious injury or death if not handled properly. The information provided in this narration is for informational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any changes to your electrical system. They can help you assess the specific requirements of the application and ensure that the installation is safe and in compliance with all applicable codes and regulations. Remember to always prioritize safety when working with electricity. Taking the time to do the job right and following all safety precautions can help to prevent accidents and ensure the safe and reliable operation of your electrical equipment. Consider all of these things when using a UPS for your motor starters. Firstly, verify the total power consumption. Secondly, get a large enough UPS, and thirdly, know how long the battery backup can keep the motors running. Fourthly, a generator is an alternative for long run times.